Hi students, the second chapter of transformation is about homothecy or called dilation. What is the homothecy? Always we need to have a center omega. Ratio cannot be 1 nor 0. It transforms every point m in the plane to a point m prime such that omega m prime equal k omega m. So what do we realize? We realize that omega m and prime are collinear always because we have vectors here, and this is called homothecy of center omega and ratio k. Let us take these examples here in this picture. Suppose here I want to have a homothecy of center omega and ratio half, and I want to find the image under the homothecy of a point m which is m prime. So I'm going to say omega m prime equal half omega m. This is omega and this is m. So omega m prime, this is omega m prime here, will be equal half omega m. In that case, m prime will be midpoint of omega m. In the second one, I want the homothecy of ratio omega of center omega and ratio 2. I want to find the image of m which is m prime. So in that case, omega m prime will be double omega m. So omega m prime will be double of omega m. So in that case, m will be the midpoint of omega m prime. So always if k is bigger than 1, okay, so you have omega, then m prime. If k between 0 and 1, you have omega m prime, then m. However, if k is negative, for example, h, you have, for example, suppose I'm going to give you center omega and minus 1. In that case, omega m prime will be minus omega m. Minus omega m, it means omega m prime is opposite of omega m. In that case, omega will be in the middle of segment m prime. Let us go to GeoGebra. I need to pick here a point A, for example, or omega. Let me put first of all omega, or W. I want to name it here W. And I want to pick a point A here and the point B. Let me see, I want to find the dilation of point A, omega. Let me pick 1.5, ratio 1.5 for both. It's A prime. From B to omega also 1.5. So here we can realize always the intersection of A prime and B prime is the double point which is omega. Always if you want to find the center of a homothecy, it will be the intersection of A prime and B prime. And if you join these two, A B and A prime B prime, they are parallel and they have the same ratio. Why? Because you have from Thales, you have our two similar triangles. You can say omega A prime over omega A equal omega B prime over omega B equal A prime B prime over AB. So that's why not only omega A prime will be K omega A or omega B prime will be K omega B, but also A prime B prime equal K AB. So here if you move, for example, if you move the point A wherever you want, always AB and A prime B prime are parallel and they have the same ratio K. Why we said omega cannot be 1? Because if in homothecy the ratio cannot be 1, because if it's 1, you're going to have omega m prime equal omega m and the 2 points are confounded, so we don't have anymore a homothecy, so we don't have an image. However, if it's minus 1, it's central symmetry. For example, if you have omega and you have a point m, I told you I want omega m prime equal minus vector omega m. So in that case, we have omega will be the midpoint of m prime m, and in that case, as if we have a rotation of center omega and angle pi. So this is called, as we know from chapter before, central symmetry, where the center ZW will be B over 2. inverse homothecy, suppose you have H center omega ratio 1 over K. So here we know from before an omega m prime is K omega m. Suppose you have H omega K and H prime, another one, same center, and K prime. We're going to realize that if K and K prime are inverse of each other, I mean here 1 over K. So we'll have, if you want to do H rho H prime, the image of the point M will be the same as point M. So let me do it in GeoGebra, and then we're going to prove it here. Suppose you have center omega and the point A. I'm going to do a dilation of the point A with omega ratio, for example, 3. So you have A prime. Now I'm going to do from A prime to W 1 over 3, the inverse of it. You're going to have the same point, which is W prime. So in that case, the image of the point A is nothing else than A. So let us prove it. So here I'm starting by point M. We have homothecy of center omega and ratio K. You're going to get omega M prime equal K omega M. So here I have a point M prime. Suppose I have now H inverse omega 1 over K. So this M prime will be M double prime such that omega M double prime equal 1 over K omega M prime. But you know that omega M double prime, which is equal half omega M prime, but omega M prime is K omega M. So if you put 1 over K times K omega M, you're going to get omega M. So in that case, M double prime and M are confounded. So M double prime and M are the same. If you have H rho H inverse of any point M is the same as point M. Now, suppose we have a transformation of point M to point N prime and N to point N prime, and suppose this transformation is nothing else as a homothecy. We want to show, if you have this case, M N and M prime and prime are, they have the same ratio. Why they have the same ratio? Because if HM equal M prime, we have omega M prime equal K omega M. If HN equal N double prime, then in that case, N prime here, omega N prime will be K omega N. Now I want to show 100%, you know it from Thales, but I want to show N prime equal K Mn. So N prime will be, we introduce omega here by Charles' rule, but N prime omega is nothing else than K omega M. Omega N prime is nothing else than K omega N. So if you put K in factor, and by Charles' rule, it's K Mn. You know it from Charles' rule, if by Thales theorem or similar triangle, if Mn, for example, equal K M prime and prime, here they are parallel and they have a specific ratio. If you join it, you're going to have similar triangle. So in that case, you're going to say omega M over omega M prime equal omega n prime omega n over omega n prime equal mn over m prime n prime. Here K is less than 1. However, here K is bigger than 1. If M prime and prime equal K Mn, then 100% we have a homothecy of ratio K. Why? Because if Mn, vector Mn here is equal K vector M prime and prime, okay, there exists a homothecy 100%, because if you join these two, okay, we have similar triangles where the center is omega. We can say there exists at least omega, a homothecy of center omega that transform, for example, A M to M prime. We want to show if we have this one, it transform also a point N to N prime. Why? Because omega N prime, if you introduce here N prime between the two, omega M prime is nothing else than K omega M, and M prime N prime, we have it K Mn, so which is K omega N. So what do you need to know at the end? Always, if you have Mn equal, if you have Mn or M prime N prime equal K Mn, there exists a homothecy that transform M to N prime and N to N prime. Thank you for listening.